Okay, last intro of this chapter says Emily, a groupie who was getting $30 per lap and had $20 in donations, wanted to walk between 8 and 16 laps during the walkathon. So question was, how much money would she raise if she met her goal? Well, we have two different pieces of information we have to find out. If she walks her eight laps, she has $30 per those 8 laps, plus the $20 in donations. So she's going to receive 240 plus 20, which is $260. If she does her 16 laps, she's going to double that. So she's going to get 480 out of this, plus the 20 is $500. Okay, so how much money would she raise? She wants to walk between those. So that means that she's going to raise between 260 and $500. Okay, let's look at this with what we've been looking at with inequalities. We know that A is the amount earned, so we know that her amount earned is going to be greater than or equal to $260, and it's going to be less than or equal to $500. So when we look at this, this is called a compound inequality because we have two pieces that we can compare. But we can also, when we look at that word and, we can rewrite this since they are related. We're going to say that the amount is greater than $260 and less than or equal to $500. So this is saying the exact same thing as this up here, but again, we are connecting them because we understand it's between those two amounts. So when we would graph this, I would have 260 down here and go by 20s. So 80, 300, 400, 500. So that means all values in between here will work between. So I'm going to connect those dots. So that's what we're going to be looking at with this section, is that if we see that it's between those, we know it's greater than or equal to this number, less than or equal to this number, which means we are going to connect them. One thing that I always tell students to look for quickly when writing this compound and inequality, smaller number is on the left, bigger number on the right. Both of your signs are facing to the left, which doesn't mean that they're both less than. Again, we always read it from the middle. The amount is greater than or equal to 260 and less than or equal to 500. So this is how you would write it, and this is how you would graph it. Okay, next up, the school was letting the groupies borrow the track, but stated in order to keep it safe, the students would have to stop walking if the temperature dropped 25 degrees or rose 35 degrees from the beginning of the walk. So question 2 says if the temperature at the start of the walkathon was 60 degrees, state the temperatures that would force them to cancel the walkathon. Again, we're still focusing on two different answers here because 60 degrees, if it drops 25 degrees, that means at 35 degrees they would have to cancel. At 60 degrees, if it rose 35 degrees, that means anything greater than 95 would make it canceled. So we are going to say temperatures lower than 35 degrees or higher than 95 degrees. Okay, so notice here we're using an or. Again, let's go back to looking at what we've dealt with these last couple sections. If we had temperatures lower than 35 degrees or temperatures higher than 95 degrees. Since we have an or, we are still going to set up our graph the same. So let's look at just doing 30 here. 40, 50, 60, well, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. Okay, this says less than 35. So I'm going to put an open sign here because I guess they'll be nice at 35, but anything lower than that. Temperatures less than, or temperatures greater than 95. So notice when we do an or statement, our arrows are going opposite directions. Less than this or less than that. Okay. Also notice that it could be 33 degrees, so our solution could be one or the other. That's why that or is there. Okay, so compound inequalities, looking at actually solving two problems together and understanding what their graphs are going to look like. Okay, so with that in mind, go ahead and get out the notes and vocab for this section. Okay, objectives are still to solve, identify and graph, solve the real world problems, and write linear inequalities. Now we're just looking at actually solving two inequalities together. So when considered together, two inequalities form a compound inequality. It contains and it also contains or, but we're going to look at the and. It says a compound inequality containing and is only true if both inequalities are true. Its graph is where the graphs of the two inequalities overlap, and this is called the intersection. And they do a really good job of explaining this here, that when we have x is greater than or equal to 3, it could be all of these values. X is less than 7 could be all of these values. But when we put them together and compare them, and we put that and in the middle, it has to satisfy both of these situations, that it has to be greater than or equal to 3 and less than 7. So these are the only numbers that will satisfy both of those inequalities. Again, make sure that we understand how to read this. We start with the middle. We realize that that does say greater than or equal to 3 and less than 7. Okay, so with all of that in mind, go ahead. We're going to look at example 1. Okay, when we are solving a compound inequality with an intersection, it is written like this, where we have our variable in the middle. Looks a little bit different, but understanding that we actually have two different equations here. We have x minus 3 is greater than or equal to negative 2, and x minus 3 is less than 4. So keeping in mind that this is two inequalities together, that means that when we do solve for our variable, we have to undo all of the operations on both sides of the inequality. So I'm going to add 3 from the middle to get my variable by itself, which means I also have to add 3 to both the left and the right. And then I'm going to go ahead from left to right. I have negative 2 plus 3. I end up with 1. My variable is by itself now, and I end up with 7. So how do you read this? X is greater than or equal to 1 and less than 7. Okay, so we solved it. Now we have to go ahead and graph that. So looking at negative 2, 0, 2, 4, 6, 8, 10. Okay, greater than or equal to 1, which is right here, and less than 7. So that is an open circle. We know it's everything in between those two values. So again, the quick check when we're solving, smaller number should be on the left, bigger number on the right, both of the inequalities pointing to the left. Looks like we have it made. Okay, this next problem is an and statement and an intersection, but they actually have the word and in there. So we're going to go ahead and solve each one individually. N plus 3 is greater than or equal to 5, and n plus 3 is less than 7. And we're going to have to figure out how to put those two together. So let's do a quick solving. We know is n is greater than or equal to 2. Whoops. It should be a 7. And m is less than 4. Okay, since that is an and statement, remember we're going to have to combine these two together. So smaller number on the left, that is going to be pointing to the left, and then bigger number to the right. So let's make sure this says the same thing. M is greater than or equal to 2. Yep. And m is less than 4. Yes. So solve them both. Smaller number to the left, and make sure both of your inequalities are pointing to the left. Now we can go ahead and just graph this. Negative 2, 0, 2, 4. Kind of a small graph, so if you wanted to open this up, you could have. But again, greater than or equal to 2 and less than 4. There's our graph. And statements, our variable will be in the middle. Our graphs will meet in the middle. Okay, so those two things in mind, go ahead and try guided practice 1. Okay, the two different kinds of problems that we looked at, we have that and statement in the middle. So solve both of them. This is a little bit tricky because we're dealing with negatives. Negative 8 is smaller than negative 5. So it should say y is greater than or equal to negative 8 and less than or equal to negative 5. Graphing that, they do both come together. This one, since they have the and statement already set up, we can go ahead and subtract 7 from both sides. R is greater than or equal to negative 1 and less than 3. And I just realized that my number was wrong over here. And I was going to comment that there is a lot of different things that we have to look at here. We have to make sure that we keep the equal sign. We bring it down. We make sure that we convey all of that greater than or equal to, so it's a closed circle, just less than, so it's an open circle. So really take your time on inequalities. Now we're going to look at the or side. It says another type of compound inequality contains the word or. A compound inequality containing or is true if at least one of the inequalities is true. So we stated that if it's 33 degrees, we're going to cancel. Or if it's 97 degrees, we're going to cancel. The union, again, we're going to look at both of them together. So one is pointing to the right, one is pointing to the left. We bring them together, they're still going to go their separate ways. When solving problems involving inequalities, within is meant to be inclusive, so that is the greater than or equal to, less than or equal to, and between is meant to be exclusive. Okay, so just kind of a nice little hint when we're doing real world type of problems, which is what we're going to see right here. It says the human ear can only detect sounds between the frequencies of 20 hertz and 20,000 hertz. So with that, I'm actually going to write that out. So we can hear between, so between, remember, is meant to be exclusive. So we can hear greater than 20 and less than 20,000. Okay. However, we're supposed to write and graph a compound inequality that describes the frequencies of sounds humans cannot hear. So everything, not that. Okay, so if we can hear greater than 20, that means that we cannot hear less than or equal to 20. Or we can also, if it's less than 20,000, we can't hear things that are greater than or equal to 20,000. So I looked at the opposite of that. Okay, so again, this says H is greater than 20 and less than 20,000. So our hertz that we cannot hear are less than or equal to 20 or greater than or equal to 20,000. Okay, graphing that is going to be kind of tricky because we have some pretty big changes there. So I'm going to start with 0 here. Each one is going to be 1,000. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10,000. 1, 2, 3, 4, 5, 6, 7, 8, 9, 20,000. Okay, that 20 is probably about right here. Again, that's less than. It's probably a little bit smaller than that. And then greater than. So story problems, make sure that we understand what we're looking at. I know that we saw that word between, but then they threw in that cannot, so we had to do the opposite of it. So this then would be the answer that we would want to circle. Okay, we're going to do the guided practice 2 together. It says the company is manufacturing an action figure that must be at least 11.2 centimeters and at most 11.4 centimeters tall. Write and graph a compound inequality that describes how tall the action figure can be. So I'm going to go back to this. At least 11.2 centimeters, so it can't be smaller than that, but it can't be bigger than this. So the way that I read it, it has to be between those two numbers. So the action figure height let's say C for centimeter, because we just used H, has to be greater than or equal to 11.2, but then less than or equal to 11.4. So look at what I just did. I created an intersection, okay? Not a union, but an intersection. All right, graphing that, since we're dealing with really small decimals, let's go ahead and use, this is 10, and then each one will be a tenth. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Whoa. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we know it's between 11.2 and 11.4. Again, read that story problem twice, reword it in your own words, and understand what we're dealing with. Am I dealing with an and statement or dealing with an or statement? Okay, now we're getting into solving and graphing those unions, those or statements. So remember that we do deal with two different inequalities. So we're going to write them both, and then we are going to graph them. So subtracting 3 from here, we know that our W can be less than or equal to 3, or our W can be greater than or equal to 2. So when we rewrite this, again, we're going to say W can be less than or equal to -3, or we do have to put that or in there, W can be greater than or equal to 2. Okay, so now let's go ahead and graph this. -4, 2, 0. Okay, less than or equal to -3 right here, filling in the dot to the left, or greater than or equal to 2, filling in my circle to the right, or statement. All right, look at one more of those. This looks like it's a multi-step, but I think we can handle it. -2m plus 7, 5m plus 12. Okay, multi-step, we know that we're going to add or subtract first. Then multiply or divide. Noticing that since we're dealing with inequalities and I just divided by a negative, I'm going to have to flip that sign. So m greater than or equal to -3. Subtracting the 12 down here. Dividing by a 5. M is greater than 5. Okay, this is weird because it looks like both of our inequality signs are going the same way. So double checking to make sure we did everything correct. Yes, we do have to flip the sign there. That is correct. So let's go ahead and graph this and see what that means to us. Okay, we have -3, so I'm going to say -4, -2, 0, 2, 4, 6. Okay, so I'm going to graph greater than or equal to -3. And then it says, or it could be greater than 5, which is right here. Well, look at this. All of those greater than 5 are included in the greater than or equal to -3. So I'm going to say included in m is greater than or equal to -3. So what does that mean? That means that our answer is just going to be greater than or equal to -3. We're not going to put or greater than 5 because we see that already. We see it in this graph, so this does not have to be in there. So this graph right here, our pink graph, is our final graph. And I'm going to leave that other one up there just so we understand why this is our final solution. So yes, sometimes when we do have a union, we actually do just get one answer because one of our inequalities is included in the other one. Okay, keep that in mind when you do guided practice 3. Okay, so 3 is pretty straightforward. We see that a is less than 3 or a is greater than 4. 3b, they actually give us the first one. We know that x is going to be less than or equal to 9. Solving the second one here, we get that x is less than 2. So again, we have our inequalities facing the same way. I went ahead and graphed both of them and realized that the solutions of x is less than 2 are included in x is less than or equal to 9. So the only thing we write down is x is less than or equal to 9, and that is what we graph. Okay, so again, compound inequalities. Get ready to basically be solving 2 problems in each one of these, understanding what your solution means and if it is graphed correctly. All right, with that, you should be ready to try the assignment for this section.